project was named Prispa, and it was our project for the Solar Decathlon Europe competition. For those of you who don't know what Solar Decathlon Europe is, it's considered to be the most important competition for sustainable architecture and applied technology. It's done for 10 years or 12 years now, and it's addressed to universities. So a group of students, it has to be led by students from faculties of architecture, engineering, design, but it can be also communication, marketing, economics, video, photography, and so on. They have to design, build, and operate a house that runs only with solar energy. It's called the Decathlon because it has 10 contests. Some of them you can read the 10 contests. Some of them are judged. There are juries that visit the house, and we presented the house and they give a score. And there are measurements. The house was fully equipped with sensors that measure the humidity, CO2 emissions in the house, how the appliances worked, and so on. And this is our team. This was the day that we received the equipments for working, and we made this photo. So we were a team with the architecture faculty in Bucharest, the university, the Technical University from Bucharest, and the Polytechnical University. And after qualifying, we also worked with the Art University. This is the house we did. So we had 2 years. I'm going to present a little bit the process. We started in the summer of 2010, and we made this qualification process. We were selected, 20 teams from 47. And we started working on the house. It was first designing. Then we did a lot of communication because building the house, we would actually had to finance the entire process. This is administrative cost, but also materials, services, consulting, and so on. And in 2012, this year, from January, we started building. We had a workspace given by the Technical University in Bucharest, where we built sub-assemblies, and also a factory in Covasna, where we also built part of the house, and we assemble it here in Bucharest in a parking line, in the parking lot. Sorry. And this is the house in Madrid. The competition took place in Madrid, and there were in the end just 18 teams, 18 projects, because 2 of them didn't make it until the end. And we met a lot of interesting people there from Japan, from China, from more teams from Spain because we were in Spain, from France, Brazil, and so on. And this was our project. I'm going back so you can see all the projects. Oops. Yes, this was it's called Villa Solar, the place where all the projects are. And it's an exhibition that takes 3 weeks. And also day by day, it's another journey. So we designed, before that, sustainability and energy efficiency in Romania. It's a little bit difficult to explain, and it's quite missing. So we thought of designing a very simple house that the general public can relate to easily. Exhibiting the house for 1 month in Bucharest, we received about 8,000 people, 8,000 visitors. And it was really easy to communicate with them because they felt that the house is a normal house that they can very easily integrate in a residential context. And after this first layer of contact, we can discuss about energy efficiency, about the solar system we used, about, for example, clay plastering that we had in the house. And they seemed to like the house, and it was easy to discuss with them. We also have 40 people that were interested in buying the house, and we sold the prototype that we competed with in Madrid. So this is the house. It's a plan, a floor plan and a section. It has an open space for living and dining, the bedroom that can be separated from the office, and simple spaces. And this is the interior, pictures taken in Madrid. So in Madrid, I'm going to explain a little bit about the competition because it's interesting. And I want you to keep in mind that this is a student project. And the interesting part was for all the students to actually, in the end, to operate the house that they worked on. So, as I told you, each day we had a different jury. So we had to prepare each day for the following juries. And some students stayed in the house and operated it. Except the measurements done by the sensors, we also had to do some tests. Like, for example, We had to wash towels and then dry them and try to keep the humidity between 3 degrees for maximum scoring. So we thought we knew the tests before, and we designed all the equipment and installation to respond at maximum to these tests. This is the kitchen, the bedroom, the office space, and bathroom and the porch. The name of the project comes from the Romanian traditional space, Romanian architectural traditional space, the Romanian porch. It's called Prispa. The constructive system, I also prepared this part because it's a civil engineering conference. So the structural system is made by structurally insulated panels with I-joist beams. It's the beams in shape of the eye, like the eye metal beams, but it's made from wood. We prepared before, this is, you can see there the I-joist, but actually this is the platform. And the students working in the space given by the university in Bucharest, by the Technical University. And this was the module. So we had to transport the sub-assemblies to Madrid and try to build a house, or at least assemble it, in 10 days. So this was a big challenge for us because we had to think about modularity, about transportation, because the transport to Madrid is really expensive. We had the money. So everything had to fit into standard trucks, because if you have oversized, it's much more expensive, and it's difficult to organize the transportation. So this, for example, this module was fit into one truck. And this is the second module. We've had to prepare first the foundation, then the first and second module, and then the walls came, the platform, the walls, and the roof. And then we just worked on finishes. The entire structure of the house was done in a little bit more than 1 day, in not more than 40 hours. The other teams were looking at us that we were almost done with the house, but after that we had a lot of work to the finishes. Energy efficiency. So the house relies on try to assure the optimal conditions, the thermal optimal conditions, make sure that all the characteristics that we had to achieve were achieved, and then minimize the energy consumption. So we relied on thermal buffers. We have the vestibule near the porch. You can see there in the winter the thermal buffer. We had the technical space in the split level, and the storage in the north part of the house. We also had the kitchen that is usually heated more because you cook there, and the bathroom that you don't necessarily have to heat that much, also in the north, and those were also a sort of thermal buffers. Then we relied on this effect that the porch creates, because in summer it shades the space and the sun doesn't enter the room and it doesn't overheat. But in winter it allows the sun to enter, and our calculation shows that it entered around 1 meter. And this meter was, we had stone paving, because the stone, as you know, is thermal mass, and it heats from the sun, and then it gradually releases the heat into the room. We also use the clay plastering for the internal walls, because it's also thermal mass, but it's also a humidity regulator. For the operations, we had an HVAC system. It did free cooling. That means it takes fresh air from outside and it extracts the hot air. And when the temperature is reached, then I wrote this down, but I forgot. Okay, so this is the free cooling. When the temperature was below -5 degrees, we use for heating radiant panels. That doesn't directly heat the atmosphere in the house. It heats the thermal mass, and then the thermal mass releases the heat. These are what the house consumes, because we had all the roof was equipped with a solar system that produced everything we consumed over a year. But as you see in the graphs, in the winter period, we actually don't produce that much, because in the summer we produce twice or even triple what we need. And we won the second place in energy efficiency. This was our time to go on the stage and receive an award. And actually what I wanted you to remember is that is maybe two conclusions. That for us was a very good experience because we worked in a very multidisciplinary team for this project, and I think this is needed. When we first saw the project and saw the Decathlon competition, we said that this is what the Romanian School of Engineering and Architecture needs, because it's multidisciplinary. Yes, you work in a really big team and you learn a lot from the others, negotiating and finding common solutions. It's a design-build project. After you design and you think of something, a solution, you actually have to build it and to make sure that it's feasible and resolve all the problems that come into this path. And it's about sustainability and energy efficiency. During this project, we had the opportunity to test all these concepts. And it's also a need for the school, but it's also an opportunity. We are trying to do this kind of competition, this kind of project here in Cluj for the next edition, and now we are preparing the qualification process. So hopefully we'll have this kind of project here in the next 2 years. Thank you.